this method as a direct method for computation of unknown variables. So this method has some drawbacks, so that we will learn today. The first drawback is division by 0. So it has a division by 0. So for example, we have a 2 instead of 3, taking 3, 4 simultaneous equation. For better understanding, I am considering here only 2 equations. So the first equation is, so there is no x1 value. So 0 into x1 minus 3 into x2 plus 7 x3 is equal to 70. And second equation, x1 minus 0.01 x2 plus 2x3 is equal to 23. So these are the 2 simultaneous equations we have. So in case of Gauss elimination, first of all, what we will do? First of all, we will compute a factor. So that factor is equal to some diagonal element. So divided by the which element you would like to make 0 divided by that element. Just a minute. So here you can see, so you can write this equation in terms of 0, this is 1, and 3 minus 0.0172. So this is equal to 17 and this is equal to 23. I have written this in terms of matrix form. So in case of Gauss elimination method, so we would like to make this as a 0, isn't it? For that, what we are doing, we are computing factor. Factor is equal to which element you would like to make 0. So that is 1 divided by, so key element. So this is first row, this is the key element, its value is 0. So you will get something by 0, this is infinity. So this leads to problems when we are computing. So this is the one, the problem exists in Gauss elimination method. So this cannot be eliminated. So this leads to error in the problem, or this system may stuck, or it may give some random outputs. So this is the one drawback, so that we cannot handle directly. So in Gauss elimination method, so this is the one. And second, so it leads to ill condition. The second one is ill condition. So here you can see. So it leads to ill condition. So this is the ill condition. So ill condition can be defined as a system whose coefficient matrix is nearly singular. This matrix becomes nearly singular. So you might have the idea of singular matrix. So all elements of the matrix contains 1. Such matrix is called a singular matrix. Is called as ill condition, or it occurs due to rounding and chopping of numbers. So this ill conditions may be lead due to rounding and chopping of the number. So as you know, so in case of integer numbers, all computer uses so number system or data type. In case of integer numbers, usually it is truncated or chopped this data up to 8 decimal places, and in case of double, so this is 12 to 14 decimal places. If it exceeds more than 14, so in that case, so it will truncate or it will chop that number up to 14 decimal places, and it will be utilized for further computation. If the particular variable is assigned as a integer, So it handles only up to 8 decimal places. If it is beyond 8 decimal places, in that case, so it will truncate or it will neglect the remaining digits, and only it will consider up to 8 decimal places. So thus the rounding off automatically occurs in computations. So these computations leads to rounding of numbers as well as chopping, and this is also called as a truncation. So truncation of a particular digit is number is occurs. So due to this, the ill condition may occur. So these are the 3 reasons which leads to ill condition: one, rounding of number; chopping of number; or truncation of numbers. So truncation of numbers, and in some cases truncation of equations also occur. So right now we are dealing with the numbers. So this is the issue which leads to ill condition. So let us see some examples how it leads to ill condition. Now you solve I have 2 simultaneous equations. You solve these 2 simultaneous equations. So I will change the sign. So here, now see, so this get cancels. So here you will get minus 0.001 into x2 is equal to 0.001. This is also minus. Now here you will get x2 is equal to 0.001 by 0.0, x2 is equal to 1. And similarly, is x2 is equal to 1 means by using first equation, so you will get x1 is equal to 1. But the same equation, so I have made little bit modification. Instead of 1.001, so I have made this 0.999 and 2.001. So this minor modification in these equations, it leads to a value of x1 is equal to -1 and x2 is equal to 3. So you can see this is the drastic change in output values. So for small change in inputs, so this is say input, and here this is also a input. So if you are made very small, see here, instead of 2.001, I made 2.301, and instead of 1.001, so I have represented this as a 0.9999. So this minor change in equation leads to this result. So this leads to this result. And again, we have some more examples. So in this case, I think this is not visible clearly. Now we have third equation, second equation, and third equation. So in this case, so you will get x1 is equal to 1 after solving. So you solve this later on and verify. So after solving these 2 simultaneously, you will get x1 and x2 is equal to 1. Now I have made some little bit changes. So here 1.01, 0.99 into x2 is equal to 2.02. So in this case, so you will get the value of x is equal to, so value of x1 is equal to 2 and x2 is equal to 1. So thus after solving this equation, you will get this value. And again, I made little modifications. So here, so in this case, so this modification, see here, the entire thing is same, but we have modified here. So instead of 2, it is 2.02. Instead of 2, it is 1.98. So here also we exchanged these values. So after exchanging these values, you will get x1 is equal to 1 and x2 is equal to 2. So like this, so minor changes in the input values which leads to drastic change in the output value. So here you will get x1 is equal to -1 and x2 is equal to 3, and here you will get x1 is equal to 1 and x2 is equal to 1. So you can see here, so the very little modification in the equations, coefficients of a variable, so which leads to different values. So such condition exists. So when you are using Gauss elimination method, so this is the one major drawback in Gauss elimination method. This is the output. A small change in input, we get large changes in output. So this situation is called ill condition. And third drawback is accumulation of round of errors, because in first iteration usually it consists of n number of iterations. So in first iteration, so suppose say this has 001 error. In second, it leads to 0.002. So it may lead to in third iteration 0.5, so and so on. So likewise, it leads to accumulation of round of errors, so in the problem, so which provides inaccurate results. So these are the, so this is related to the accuracy. So it leads to less accurate values, so due to accumulation of round of errors. So these are the three major drawbacks this elimination method have.